All right, guys, so we're gonna test out something pretty dang crazy. Do you see that thing in back of me? That is a bead launcher, or a bead, what is it, a tire bead air compression cannon. And basically we're gonna use this to measure how barrel length affects the time that a ball or a projectile is launched into the air. So this is really, really cool. We're gonna be using about 20 PSI. So we're gonna have a constant variable right there. But yeah, let's get right to it. So essentially what we're gonna be doing is we're gonna be hooking up an air pressure tank. This is like a 50-foot hose. It's connected to an air pressure tank, and we're gonna be hooking it up right here, putting a constant pressure of 20 PSI. And we're gonna be getting this barrel right over here, and we're gonna be cutting it about 2 feet down each time to see how it affects the amount of time the projectile is in the air. Okay, so now we have about 20 PSI in here. Let's get that out. And we're gonna get this projectile. This is a Nerf bullet. I'm using someone that I know from church. I'm using their backyard, so this is great. But we're gonna put this thing into this cannon, and then we're gonna measure it. Okay, so we got 20 PSI in the tank. This is the trigger right here. This is the barrel. This is 8.5 feet long, or tall, long, whatever. We'll just say it like that. Well, watch this, guys. This is gonna be crazy. 3, 2, 1. Oh my gosh, where'd it go? Oh, I can hear it, and that's it. That's crazy. Okay, so I went to go grab this thing. This thing was up in the air for 10.5 seconds, basically. That is insane. That is so crazy. Okay, so now we're gonna cut this piece of PVC pipe, and we're gonna cut it about a foot down. We'll go about a foot. So we'll get to 7.5 feet, and we'll see how that affects the time that this thing is up in the air. Okay, we shorten it down. Let's do this. Holy cow, that was insanely hard to cut that. Okay, that was crazy. Okay, let's do this. Watch this, guys. Holy cow, that thing went so high. Where'd it go? Oh, I see it. I see it. It's right there. It's right there. I think I'm following it. Boom, baby. Oh, those horses are probably freaking out. Okay, so as we're looking for this ball, all right, we're gonna talk about pneumatic cannons and how they work. So basically, we're filling that thing up with pressurized air using another air tank, right? And making that go up to 20 PSI, we have a chamber that's filled with tons of air, okay? And basically when you pull that trigger, it just releases a valve and it just goes, and all of a sudden the air basically evacuates the system, okay? It's dipping out, it's going, it wants to leave, because out here, there's not as much air as there is in there, you know? Being like pressure per square inch, right? Per square inch, that's PSI. We're gonna have more pressurized air within that area. All right, so essentially, we went from 10.34 seconds to about, whatchamacallit, 9.81 seconds. That is insane. That is almost like a half a second difference. Actually, I think that's legit. That is like a half a second difference. So what we're gonna do now is we're gonna see how drastic of a difference this changes as we go about, let's go about another 2 feet. We'll do another 2 feet real quick. By the way, the equipment I'm using is that, a Sawzall to cut this, got the tape measure, of course, and then my thigh to help it out. So this is gonna be good. Let's do this real quick. Let's get it cut, and yeah, for science. Look at that beauty. That is so good. That is 2 feet right there. It might be at an angle. I'm not the best sawyer. Okay, I didn't blow up with tools, but hot dang, this looks good. Go like that. Good to go. Now I'm just gonna cut that in, and then let's get this thing rolling. So let's do this. Let's launch this thing. We're at 20 PSI, 4.5 feet. This is gonna be crazy, dude. This is kind of like sketchy having this like right next to my face. Okay, let's do this. Okay, hand is on the trigger. 3, 2, 1. Oh my gosh, that went in back of me. I wonder where that's gonna hit. Okay, you guys are still with me. 3, 2, 1. Bam! Okay, that was like actually about 9 seconds as well. That's interesting. Okay, so I did the data. It actually went about 9.83 seconds. So it was a little bit crazier, like just a little bit farther. So that's interesting. I wonder if I miscalculated a little bit before, because if this is correct, okay, that first one was supposed to have that first barrel length, which was 8.5 feet, was supposed to be, you know, the largest, and then the second one was supposed to be a little bit less, you know, so we had 9.81 seconds, and this one's 9.83, so that's kind of weird. But either way, it definitely is staying in an area of being at 9.8 something seconds. So I wonder if we kind of hit somewhat of a plateau in our data. But we're gonna cut this one more time. I wasn't going to, but now we are. And this is gonna be legit. Let's see how far, how high this thing goes, or how much time it's in the air. This will be super quick. 2.5 feet. Okay, I'm kind of holding my phone in an awkward position. But look at this barrel. This is like nothing, okay? When we were beginning this entire project, this thing was 8.5 feet. Now it's at 2.5, 3 feet. My expectation, my hypothesis, is that this thing is going to only go probably for about 9 seconds. But after this, we're doing a Hail Mary, okay? And it's gonna be wild. All right, so we got the trigger right over there. Of course, this is such a short barrel. My head is literally like right up to here, okay? That's probably about like a foot. That's insane. But let's see how this goes. So we're at 12 seconds on this clock. 2, 1, boom. Okay, so we got about 9.5 seconds. So now we're going down pretty good. Okay guys, we are 6 times the amount of PSI that we did on this thing before. So you know how it was going like 9.5 seconds in the air? According to the person that owns this thing and has played with it quite a bit, this thing is going to launch possibly, what was it, like 1,500 to 2,000 feet in the air. So let's try this out, guys. This is gonna be crazy. Okay, 3, 2, 1. That thing's dead. Guys, we gotta go save our buddy. This is crazy. What the heck just happened? So it went into 2 pieces and it was like super close, okay? Oh shoot. This poor guy. Oh my gosh. What happened to you? Where's your buddy? Oh my gosh, he's like not even that far. Okay. Well, I owe him a new football. Now I do. Gosh dang it. Oh yeah, I'm bleeding. That's crazy. All right, so what did we learn while we were out on the field? Let me tell you. First off, physics is absolutely fantastic. And not only that, but the longer the barrel length of a gun or something like that we were using, which was a pneumatic cannon, the longer the barrel length, the farther a projectile can go. And I did some more research on this, and there's actually kind of a sweet spot that we can possibly get to depending on the cannon and the diameter of the barrel. But anyways, with this cannon, it was absolutely fantastic to be able to see that as we went, as we cut down the barrel to get shorter and shorter, it didn't go as far. The projectile didn't go as far. And not only that, but there's actually a reason behind this. We put a lot of pressure near at the end, correct? We had a lot of gas that was actually within that cannon. And in turn, it actually shot the projectile out way too fast, okay, and actually blew it apart. But if you could see, I think you could see it near at the end, there's a little bit of gas that was coming out. And what that means is that there's expanding gas. And so what it does is that when you have a longer barrel, it allows that expanding gas to continue to propel that projectile out of the cannon. So it gives it a longer time to be able to push it out. And like we said before, you know, the longer, like if it's a super long barrel, if it's too long, it'll actually diminish its ability, that gas will diminish its ability to actually push that projectile as far as it can and actually create friction within the barrel, thus not allowing that projectile to hit that maximum speed that it can go. But this was a super cool experiment, and I'm actually definitely going to buy one of those things because I still want to play with those things, possibly with a tennis ball. Who knows? If you want to come, you can. But anyways, it was awesome and definitely have enjoyed it. Now we're going to talk about something that I did really quick. And that was actually with a potato cannon that was actually going to be used for this experiment, and how you can actually make it fail and how you can make these things fail. Alright, so now when it comes to the Capstone project, this is what we started off with. This is a potato cannon. We switched to using a pneumatic cannon, which basically uses compressed air. but this uses combustible air. And this is just something that I want to put out into the future, is that these are awesome. These are phenomenal at being able to work with when it comes to measuring barrel length and the effect it has on a projectile being able to be launched as far as it can go. But with this being a potato cannon, and being that we have this hole right over here, there are definitely some other variables, and knowing for sure that being able to have a consistent variable, constant pressure being applied to that projectile as it's being, with that gas being in the chamber, it is a big deal. So with the pneumatic cannon, it was definitely a lot easier, knowing that we had a constant PSI being pressured in the chamber and then being able to be launched depending, and having that effect depending on what the length of the barrel was. But anyways, thank you guys so much for watching my capstone project, and I'll see you guys later.